Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for random variable. The continuous random variable x has a probability density function given by the situation. So my suggestion is to express the situation in a number line. Then kindly locate the situation where we have 0 until 1 for the function kx, from 1 until 2 for the function kx squared. Then otherwise we have the function 0. A shows that k is equal to 6 over 17. So as we all know, the summation for the function will be equals to 1. So means that integrate from 0 to 1 for the function k x with respect to x plus integrate from 1 to 2 for the function k x squared with respect to x will be equals to 1. So integrate the situation. So where we will have x squared over 2. So meaning that we have k over 2, then with the limit 1, 0. Next, integrate the x squared, where we have x to the power of 3, bracket, k over 3. For the limit to 1 is equals to 1. Substitute the situation. So here we will have k over 2, bracket, 1 minus 0, plus k over 3, bracket, if we substitute 2, we will have 8 minus 1 is equals to 1. So k over 2 plus with the situation 7k over 3 is equals to 1. So kindly multiply all the terms with the 6. So we will have 3k plus 14k is equals to 6. So finally we have 17k is equals to 6. K will be equals to 6 over 17. And we already shown the situation. Next, substitute the value k into the number line. Next, what we have to do is to find the cumulative distribution function. So for number 1, where we have the domain, t is less than 0. For the function, integrate from negative infinity until t for the function 0 dx, and we will obtain 0. So ft is equals to 0. For the second one, where we have t is greater equals to 0, less than equals to 1. For the function, integrate from negative infinity until 0 for the function 0 dx, plus integrate from 0 until t for the function 6x over 17 with respect to x. If we integrate the situation, and we will have f0 plus with 6x squared over 17 multiplied with the 2, limits t and 0. So if we simplify the situation, and we will have ft is equals to 0 plus with the situation 3t squared over 17. Next, number 3. For the domain, t is greater equals to 1 and less than equals to 2. For the situation, integrate from negative infinity until 0 for the function 0 dx, plus integrate from 0 until 1 for the function 6x over 17 dx, plus integrate from 1 until t for the function 6x squared over 17 dx. So focus on this part, and we can replace the situation with f1, plus where we have 6x cubed over 17 multiplied with 3 with the limit t and 1. So kindly substitute the 1 into this part. So we will have 3 over 17 plus bracket, we have 2t cubed over 17 minus 2 over 17. Simplify the situation. So where we will have ft is equals to 2 multiplied with t cubed over 17 plus with 1 over 17. As for the final part, where we have t greater than 2. For the situation, integrate from negative infinity until 0 for the function dx, plus integrate from 0 until 1 for the function 6x over 17 dx, plus for the function 1 until 2 for the function 6x squared over 17 dx plus from 2 until t for the function 0 dx. So for this part, we can substitute f2 plus with the 0. Kindly substitute the 2 over here and we will have ft is equals to 1. Next, express the situation in a cumulative distribution function. So for the fx, where we have the first one is the function 0, followed by 3x squared over 17. The third one will be 2x cubed plus with the 1 over 17. And finally, we have 1. So kindly state the domain where we have x less than 0. For the second function, x is greater equals to 0 and less than equals to 1. The third one is x is greater equals to 1, less than equals to 2. For the final one, x is greater than 2. So here we have the cumulative distribution function. Kindly focus on the question C. Find, correct to 2 decimal places, the median m of the situation. So step number 1 is to test where is the location for 0.5. So focus on the second function. If we substitute 1, and we will have 3 over 17. 3 over 17, or we can say 0.176, which is less than 0.5. So means that the location for 0.5 is not located in the second function. Next, fm is equals to 0.5. So kindly substitute into the third function. So where we have 2m cubed plus 1 over 17 is equals to 1 over 2. Rearrange the situation. So where we will have 2m cubed plus with the 1 is equals to 17 over 2. M cubed is equals to 17 over 2 minus 1 over 2. So m cubed will be equals to 15 over 4. So m will be equals to cube root of 15 over 4. So m will be equals to 1.5536. So correct into 2 decimal places. So the value of m will be equals to 1.55. For the question D, find the correct to 2 decimal places for the situation. Probabilities that x is minus m. Probabilities that with the modulus x minus m less than 0.75. So previously, we already determined the value of m, which is 1.55. So define the situation. So probabilities that x minus 1.55 is greater than negative 0.75, less than 0.75. So probabilities that x is greater than 1.55 minus 0.75, less than 1.55 plus 0.75. So simplify the situation. Probabilities that x is greater than 0.8, less than 2.3. So by referring to the situation, so where we have the maximum is 2. So in here we have f 2.3 minus the capital F 0.8. So kindly refers to the function. So here we have the maximum is 2. So means that what we can do is for the f 2.3, so means that we have to refer to x greater than 2, where we have 1, minus f for 0.8. So the 0.8 is located for the second function. So 3 multiplied with 0.8 squared over 17. So simplify the situation. 1 minus 48 over 425. So simplify the situation. So we will have the probabilities that modulus x minus 1.55 less than 0.75 will be equals to 377 over 425, or you may express the situation 0.887. So as a conclusion, correct to 2 decimal places. So we have our final answer 0.89. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.